Chapter 13, first section, using trigonometry with right triangles. All right, new stuff, very fun. So a triangle that is a right triangle has ratios that are involved. If you've got a right triangle, you know that the side opposite that right triangle is the hypotenuse. And so these ratios, and you probably have used them before, I hope you have. These ratios have to do with the ratio of the relationship of the different sides to the angle theta, and we're just calling the theta is the angle that we're involved in, or that we're interested in. So what I'm going to do is we're going to do this first problem as I talk you through the different ratios. Because these are, oh, I didn't write it all up. Your first section in your homework is going to say, write out the six trigonometric ratios for this triangle. All right, and so here's what they are. The first one is sine of theta. The sine of an angle is the ratio of its opposite side to hypotenuse. So what that means is you go to the angle theta and you want the side opposite the angle over the hypotenuse. So it's going to be 7 over the hypotenuse. Now, you're saying, well, I don't have the hypotenuse. I don't know what it is. Well, you know what? You know how to get it. Because if you have two sides of a right triangle, you can find the third. Because remember Pythagorean? I love him. So 7 squared, a squared plus b squared equals c squared. 7 squared plus 24 squared equals c squared, or your hypotenuse squared. So 7 squared is 49. 24 squared, do it in your calculator, quick, quick, quick. I can beat you. 576, and that equals 625 equals c squared. So the square root of that is 25. So your C is 25. All right. So do you see how I did that? To find, if you know 2, you can find the third one by using Pythagorean. So now we go back to, now we have the 3 sides. So these are quick and easy. So the sine is opposite over hypotenuse. So 7 over 25. Cosine is adjacent over hypotenuse. Adjacent means next to. So the side, the leg that is next to theta is the 24. And that's going to be over the hypotenuse still. Tangent is opposite over adjacent. So the tangent of theta, so you always start with the angle in question. So the opposite is 7 over the adjacent, which is 24. See where I'm getting them? So once you know all 3 sides, if it's a right triangle, this is really easy to figure out. Now, cosecant is the reciprocal of sine. Cosecant is the hypotenuse over the opposite. So if you know sine, you can just flip it, or you're going to do the opposite of sine. Your cosecant is going to be the hypotenuse, which is 25, over the opposite, which is 7. And you see how it's just the reciprocal of sine. Secant is the reciprocal of cosine, and so it's going to be the hypotenuse over the adjacent. So you go to the hypotenuse, and you put that over the adjacent side, which is 24. Cotangent, surprise, surprise, is the reciprocal of tangent. So instead of opposite over adjacent, it's adjacent over opposite. So 24 over 7. And that's all you do for those. Now, if you are given the sine of theta is 4/7 or whatever, if you're given a sine and you want the tangent, what you'll need to do is, in this case, you'll need to come up with your own triangle. You'll need to draw it to see what the relationships are. Ooh, lovely triangle. So here's my right angle. And if the sine, if this is theta, if the sine is 4 to 7, then the sine, remember, is opposite over hypotenuse. So the opposite would be 4. The hypotenuse would be 7. And if you want the tangent, you want the opposite over the adjacent. So you want 4 over something. And how did we say we can find that something? Same thing, it's going to be Pythagorean again. So this time we're going to have 4 squared plus the unknown plus x squared equals 7 squared. Woo, not 72, 7 squared. Oh, that's just lovely. All right, so now 4 squared is 16 plus x squared equals 49. Subtract 16 from both sides. 16. Oh, I'm just having a hard time. So x squared equals 33. And so here's where it gets tricky, and it's going to be, oh, I can't do this. You can do this. Because the square root of both sides is just the square root of 33. Leave it the square root of 33. All right? A lot of these, not always, sometimes we'll use decimals in these, but a lot of times just leave them the square root, all right? So now my tangent is the opposite over adjacent, so it's going to be 4 over the square root of 33. And if you'll remember, we cannot have a square root in the denominator. It's not simplified, so you have to rationalize. Do you remember how to rationalize the denominator? Multiply by the square root over the square root, because if we're multiplying by the same thing on numerator and denominator, we're just multiplying by 1, which doesn't change the value. So multiply across, and your final answer is tangent of theta equals 4 square root of 33 over 33. That's what you're looking for. All right? Whoo-wee. Moving on. All right. So now that has to do with if you've got if you've got all of the parts, and if you've got everything labeled nice and neatly. But if I want to find parts and pieces, but I don't have 2 of these sides, I can still find it. If you look on page 853, page 853 shows you certain trig functions for the values of 30 degrees and 60 degrees and 45 degrees. Those have special, those come up a lot with the right triangles. And so what you can do is, if you have, in this case, if you have something that is, well, we want the, instead of just saying theta, what we can do now is put values to it instead of, if we don't know what this is. So if I want, in this case, this is, the angle that I have is 45 degrees. So the parts that I want are the adjacent and the hypotenuse. So I know, well, I want to know the adjacent and hypotenuse. And so you look to see, well, what trig function is adjacent over hypotenuse? And if you'll look, that's going to be your cosine. So the cosine of 45 degrees is going to be this x over 6. And that's great if we only knew what the cosine of 45 degrees is. And if you'll go to that chart on page 853, it will show you, it's a whole chart with all 6 trig functions, all 6 values of cosine, or of 45 degrees, all 6 values of 60 degrees, and all 6 values of 30 degrees. All right, and so those might be, some of those might be good to memorize. Hint, hint. All right, so if you look at that chart, it tells you that the cosine of 45 is square root of 2 over 2. So if the square root of 2 over 2 is the cosine of 45, then we can set square root of 2 over 2 equal to this x over 6. You see what I'm doing? So all of these, if we have a degree measurement for our angle, then we can find a value for that sine or cosine or tangent. All right, and we can use that if it's 45 or 30 or 60, we can just use a chart and quickly and easily get one of those. So that's what we've done here. So the cosine of 45 we found in our chart is square root of 2 over 2. I know the ratio of the sides is x over 6. So now I have an equation that if 6 is our common denominator, our LCD, so, oh, I say 6 and then I write 2. Oh my goodness. All right, if I multiply both sides by 6, now I get x equals 3 times the square root of 2. So this length of this side is 3 square root of 2. All right? Okay, so now what we can do with this information, we can find all of the parts and pieces of a triangle. Now, sometimes we have the 45 or the 30 or the 60, and we can quick and easily just use that chart. You probably already know that there are sine and cosine and tangent buttons on your calculator. All right. So what you can do is you can use those buttons to get, if they're not quick and easy in your chart, you can punch those in and you can get a decimal equivalence for those values of those ratios. So what that does is we can solve a triangle. So what I mean when I say solve this triangle, I mean find all of the angles and find all of the lengths of all of the sides. All right. Now, I will have to give you a couple of pieces of information to start with. And what I've done so far is I've given you this triangle, and I've said that angle A, the capital letters are the angles and the lowercase letters are the sides. I've given you that angle A is 54, and this box, you know, means that angle C is 90. All right. And I've given you that side C is 20. So what I want you to do is I want you to solve all the parts and pieces. So what you can do is this. The first thing you can do is you can quickly and easily find the third triangle, or the third angle of your triangle, if you'll remember that the three angles of a triangle add up to 180. All right. And now another shortcut is if the three add up to 180 and you have a 90 degree, that means the leftover two have to add up to 90. So to find the third angle, all you need to do is take 90 degrees minus this 54 degrees. So then we find out that B is what, 36? So B is 36 degrees. Easy? All right, so if you know two angles, the third angle is easy to find. Now, we need to find these other parts and pieces, and I'm going to need a bigger area to write on. So, while you finish copying down, I will erase. What we're going to do is we're going to need to see what the ratios are, what the comparisons between the sides are, and then we can use those pieces and our calculator to find the parts that we're missing. So what we're going to do is we know we've got angle 54. Well, actually we have 54 and we have 36, so you can work either direction. I believe I worked with 54 just because that's what we had already. And so what I did first was I said, well, let's go with sine first. So the sine of 54 degrees is going to be the opposite over the hypotenuse. And the opposite is one we don't know, so that's A. And the hypotenuse is 20, and we know that one. So you've got to pick at least one of them that you know, all right? You can only have one unknown and solve it. So what you're going to do is this. If you will put sine of 54 into your calculator, and I believe if you're using an iPhone, you can put the number in first and then hit sine. If you're using your scientific, you hit the sine and then the number. And I think those are actual numbers on your keypad. I don't think you have to go into a menu. All right, so if you will key in sine of 54 degrees, you get, what do you get? 0.81. So the sine of 54 is 0.81. So now 0.81 equals A over 20. So to solve for A, you simply multiply both sides by 20. And when you multiply both sides by 20, you get roughly 16.2. So A is roughly 16.2. All right, and so now B is going to be the same idea, except that now if we're going to work with the angle 54, we're going to have the adjacent over the hypotenuse. So that's cosine. So the cosine of 54 degrees is going to be b over 20. And when you put in cosine of 54 degrees, be careful. You know what? I didn't tell you this. Make sure that your calculator is set in degree mode, because there's degree mode and there's radian mode. And I think in the next section we'll start talking about radians. And that's a different measurement of a part of a circle. And so make sure that your calculator is in degree mode, because otherwise these numbers aren't going to be matching up. So if you're having trouble, that could be why. All right, so 54, the cosine of 54 should be 0.59. So 0.59 now equals b over 20. So to solve, you multiply both sides by 20. And so you should end up with 11.8. And so b is roughly equal to 11.8, and you're done. So when I say solve a triangle, that's what I mean. I want all 6 parts, all 6 unknowns. I want to become known information. All right, so one last problem. You know that I wouldn't let you go without a word problem. So we're going to take that information and we are going to find the height of a flagpole. So I've got from a point on the ground 28 feet from the base of a flagpole, and the angle of elevation to the top of the flagpole is 63 degrees. What is the approximate height of the pole? Now here's the deal with these. The angle of elevation means the angle from the ground up to, so if I'm looking up at the flagpole this direction, the angle from the ground until I see the to the line of the angle here, that's the angle of elevation. Now, I think it's called what is it called? The angle of the depression. That's what the angle of depression is if you go from the sky and then down to me. So that degree, that angle is actually going to be the same. The angle of depression is going to be the same as the angle of elevation. So those two words you might need to make sure you have available to you. Okay, so if you're going to do one of these, what you need to do is draw yourself a little picture and look to see what parts you have and what parts you need. So I'm going to draw my little flagpole here, and here's my little guy here. And you don't have to really draw the pictures. I just thought that would be fun. Okay, so then what you've got is here's your right angle at the flagpole, and this, we said we are 28 feet away from the flagpole. And the angle of elevation is this angle where he's looking up. So this is 63 degrees. And what we want to know is the height of the flagpole, so this h. So the hypotenuse we don't care about. And so if you'll remember, the ratio that doesn't include the hypotenuse is the tangent. So we are going to want to use the tangent. And we want the tangent of this 63 degrees. And the tangent, if you'll remember, is the opposite over the adjacent. So the opposite is your h, and the adjacent is the 28. And if you plug in tangent of 63 into your calculator, that's 1.96. And that's going to equal h over 28. And we're going to solve it just like we just did these others. Just multiply both sides by 28. And so the height of the flagpole is approximately 55, and we'd have to put 55 feet, and then we're done. All right, so the biggest thing here is make sure you've got all of the different the different ratios. Make sure you know those. All right, it's okay to have them in your notes, and that's grand, but you need to just know those. Okay, know what those it's not really that hard. And you know what, I've heard a shortcut or a mnemonic device, SOHCAHTOA. So meaning, let's see here. SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So if you remember SOHCAHTOA, that will help you to remember your ratios. All right. Good luck. See you soon.